All right, we're moving on to section 4.9. In this section, we want to learn how do you graph quadratic inequalities and how do you solve quadratic inequalities. So there's kind of two separate parts in this section. So let's start with the graphing quadratic inequalities first. It's very similar to when we graphed linear inequalities. So when we consider graphing inequalities, we have to consider shading. We have to consider whether our graph is a solid line or a dashed line. Okay, so it's very similar. So we're just extending this to parabolas. Okay, so when we graph these, we have to identify what form we're in and how we're going to graph it. Okay, so looking at this one's in standard form. So when we graph a parabola that's in standard form, we have to find the vertex first. Okay, to find the vertex, we use the negative b over 2a to identify where the vertex is. So in this case, it'd be negative 2 over 2 times 1. Coefficient is 1 there. So that's going to be negative 2 over 2, which is negative 1. Okay, so then we plug that back into the equation to figure out the y-coordinate of the vertex. Negative 1 squared, 2 times negative 1 minus 8 gives me positive 1, negative 2, negative 8. So that's negative 9. So combining those, negative 1, negative 9 is my vertex. So I'm just going to create an xy axis over here. So I have to go to negative 9. This is my lowest point, so I should be okay there. So that's also my line of symmetry. Okay, what's the other convenient point to find? It's the y-intercept. Okay, so if I made a simple little table here, because I know I have to find the y-intercept, when I plug in 0, I get negative 8. So I can plot that point and reflect it over to this side. And then I have to find one more convenient point. So I would plug in 1 here. I can do this in my head. I think 1 squared is 1. 2 times 1 is 2. So I got 1 plus 2 is 3 minus 8 is negative 5. 3, 4, 5. Reflect that over to the other side. There's my points for my parabola. Before I draw it though, I have to look at the sign. Is it solid or dashed? Okay, it's greater than. Doesn't have the or equal to, so we know it's dashed. I'm going to draw a dashed parabola here. Like that. Now we have to consider the shading. So am I shading inside the parabola or outside? Okay, so just like with linear inequalities, we're going to test a point. So just like the other ones, the easiest point usually is 0, 0. So if I substitute 0, 0 in, we try to see if that's true. Okay, so let's try 0. If x is 0 and y is 0, I get 0 is greater than 0 plus 0 minus 8. 0 is greater than negative 8, which is true. So we would shade to where 0, 0 is, which is on the inside. So it would look something like that. Okay, so this isn't anything new. We know how to graph parabolas. We know how to deal with inequalities. So it's just kind of combining those. Let's look at another one. Here's a system of inequalities. Okay, so now we have to graph both and find the common region. Okay, so let's look at this first. Y is greater than or equal to x squared. So let's make a table for that one. Go from negative 2 to 2. Again, these ones are in standard form. Without the b, we just make a table. So negative 2 squared is 4. Negative 1 squared is 1. 0, 1, 4. So that graph is going to look like this. And now it's greater than or equal to, so it's a solid line. Okay, so now we can try to test the point, but we can't try 0, 0 this time because it's on my graph. Okay, so let's try, I don't know, we can try this point, 0, 1. If if I plug 0 in for x and 1 in for y, 1 is greater than or equal to 0. That's true, so I would shade above. Now I'll shade lightly because I have to shade the common region between the two. So now let's make a table for this one. Let's see what we get. Okay, so I have a negative x squared plus 5. Okay, so be careful with this sign here. We have to square and then multiply by negative 1. So negative 2 squared is 4. This makes it a negative 4 plus 5 is 1. Negative 1 squared is 1. This makes it negative 1 plus 5 is 4. 0 gives me 0 plus 5. And this is going to be a 4 and a 1 again. So I got negative 2 is 1. Negative 1 is 4. 0 is 5. 4, 1. Okay, so this one opens down. Now notice dashed. Gotta make sure I draw dashed. Okay, and now I test the point. Less than. So we can try 0, 0 this time because it's not on this one. If I try 0, 0, I'd get 0 is less than or equal to 5. Which is true, so I'd shade below this one. And I'm shading above this one, so I shade darken in the common region, which is this football shaped region right there. Okay, so that's a system of inequalities. Okay, so that's how we graph quadratic inequalities. So that's question 1. Question 2, how do you solve quadratic inequalities? Okay, so let's move on to that. So here is a quadratic inequality that we solve. Notice we're not graphing, there's no y here, it's just an equation with one variable. So we can solve an equation with one variable. If it's an inequality though, there's a range of solutions. So the way we solve this, and there's a couple ways they show you in the book, I'm going to focus on one way, and that's by finding the critical points, they're called. Okay, so all I'm going to do is take the inequality sign and substitute an equal sign in there for it. And then I'm going to solve that equation like I would a quadratic. So I got to get this over to one side, set it equal to 0. And then I have to solve that. So there's a few ways we know how to solve it. First way would be to try to factor, or we could use the quadratic formula. But in this case, factoring would be the easiest because it's factorable. Okay, so in this case, it's a simple diamond problem. Two numbers that multiply to get negative 15 that add up to negative 2, which would be negative 5 times 3. So it would be x minus 5, x plus 3. Okay, so my solutions then would be x equals 5 and x equals negative 3. Okay, so those are my critical points. Those are the values that I'd plug in here that would get me 15. Okay, but we want to know what values give me more than 15. So what we're going to do is we're going to plot these on a number line, real simply. Okay, so let's just say that's 0, here's negative 3, here's positive 5. I'm going to put open circles here, and they're going to be open circles because it's not or equal to. So that just indicates that those values give me something that's equal to 15 but not greater than 15. Okay? So now my solutions, the values of x that give me values that are greater than 15 are either in between here or they're outside of here. And we have to just figure out where. So all we have to do is test a point. And I always test a point in between here. Okay, so pick a number between negative 3 and 5 and test it. So in this case, what do you think is the easiest number to test? It'd be 0. So let's try 0. Okay, so we're going to try. Okay, so then I'd get 0 squared minus 2 times 0 is greater than 15. So is 0 greater than 15? No. Okay, so therefore my solutions are here and here, outside of that. So any value between negative 3 and 5 will not work in that equation, but the values outside will. So then my solution is x is less than negative 3 or x is greater than 5. Okay. All right, let's try the next one here. Okay, so again, same thing. We're going to I'm going to skip a step here. I'm just bringing this over and substituting an equal sign in there, and we're going to solve that. Okay, so now we look at it either quadratic formula or factoring. So let's try factoring first. I think we can factor this. Multiplying those, we get -8, -7 there. This is going to give me -8 times 1. So then I've got the 2, I got to do the grouping, 2x squared minus 8x plus 1x minus 4. Okay, so I'm going to factor 2x out of there. Gives me an x minus 4. And I can just factor a 1 out of there and get an x minus 4. So then I'm going to get a x minus 4 and a 2x plus 1. Okay, so x equals 4. And if I set this equal to 0 and solve it, bring the 1 over, divide by 2, I believe I'm going to get -1/2. Okay, so number line, 0, and here would be -1/2 there, so we'll do that, and this is 4. Let's make this an or equal to, because we didn't have an or equal to yet. Okay, so if it's an or equal to, I fill in the circle to indicate that those values are part of the solution. So let's test 0. Plug that in. We can do it in our head here. I get 0 minus 0. Is 0 greater than or equal to 4? No. So my solutions again are on the outside. So we write our solutions as x is less than or equal to -1/2, or x is greater than or equal to 4. Okay. One last one here. We're going to bring the 3 over and set it equal to 0. Now on this one, if I try to factor, I got a -6 and a 2. If I look at that, I don't think I can solve that. So if that tells me that that's not factorable. Doesn't mean it's not solvable though, but we're going to have to use a quadratic formula on this one. Okay, so quadratic formula, -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, so let's see, we got -2 plus or minus. I like to leave that part for the end. So let's see, we're going to have 2 squared is 4. This times this times this is going to be 12, 24. Negative times a negative is going to be a plus. Plus 24. So that's going to give me 28 under the square root. Okay, so I got -2 plus or minus the square root of 28 over 4. But now we can actually simplify this 28 if we wanted to, because 4 goes into that, 4 times 7. So that's going to be 2 square root of 7. Okay. Now the problem is this is hard to put on a number line. So we actually, at this point, have to figure out the decimal solution to this. So we actually have to figure this out on our calculator. So when I do that, I'm going to have 2 solutions. So I'm going to get -2 plus whatever this is. And if I do that on my calculator, I believe I get 5.29 over 4. And then I've got -2 minus 5.29 over 4. 2 separate answers. Now we have to add the top before we divide. So add what's on the numerator before we divide. And we get 0.82 there. And then here I'm going to subtract up here. So I'm going to get -7.29 divided by 4, which is -1.8 as my other solution there. Okay, so now we create our number line. Here's 0. And it doesn't really matter. Let's just say this is 0.82 there. And this is -1.8. All the number line is a visual. Okay, it's or equal to, so let's fill those in. Let's try a point in the middle. 0 happens to be in the middle again. So let's see, we get 0 plus 0 is 0. Is 0 less than 3? Yes, it is this time. So my solutions are in between. Okay, so now how do we write this as an inequality? All these other ones, they ended up being OR inequalities. It's either less than -3 or it's greater than 5. Those are the two locations where a solution is. But this is what, if you remember, it's called an AND inequality. So the way we can write that is put the lower number on the left, bigger number on the right, put the x in between, inequalities open to the right. This one's an OR equal to. Okay, so the way you would read that is x is greater than or equal to -1.8 and less than or equal to 0.82. So it's all the values in between those two numbers. Okay, so that's how we solve quadratic inequalities. And we are finished with section 4.9.